Hey everyone, geophysicist Stefan Burns here with an impromptu update, but as the situation calls for it, here I am live describing what is happening right now, and what we're seeing is a dramatic increase in certain frequencies of the Schumann resonances. This is resonance amplification, and this is well associated with high magnitude earthquake activity. We often see these sort of anomalous signals before earthquakes and even during earthquakes. And we can see them before earthquakes occur, like big magnitude 6, big magnitude 7 earthquakes, or even larger, 7.5 and greater. A few days before, even like weeks. And sometimes we see an increase just in general of these anomalies in the months leading up to a big earthquake. Namely, for example, the magnitude 8.8 megaquake. We had a few examples in May and June of these anomalous earthquake signals, which I thought were kind of flukes at the time because we didn't have a big earthquake a week later. Well, it turns out we had the magnitude 8.8 megaquake end of July. So they were actually preceding the largest earthquake that we had had since 2011 in the months before. So what we're seeing right now are these highly anomalous energy signals in the Schumann resonances. I'm going to explain what the Schumann resonances are. I'm going to talk about these in depth. We're going to look at some past examples of these pre-earthquake signals, how they effectively were telling us that something big was coming. I'm going to give you my highest likelihood zone for a large, like a high magnitude earthquake to occur. I think the most likely zones right now would be Central Asia, California zone. Like that could even include up to like Oregon, Washington, but West Coast of the United States, specifically California and Japan. Those are like the top 3 right now, I would say. But we'll talk about it in depth, and then we'll do a viewer question and answer. So it's not often that I have to do these sort of presentations because these are quite anomalous, and these are some of the best looking pre-earthquake signals that we've had going back to when I first started tracking this, which was really in 2023. I was really looking at the Schumann resonances back in 2021 and 2022. But it wasn't until 23 that we started to notice, at least I started to notice, these pre-earthquake signals. Specifically back in February of 23, we had these signals pop up in a very similar manner before the 7.8 and 7.5 earthquakes that struck Turkey near the Syrian border, close to the town, well, the city of Gaziantep. So a lot to discuss in this video. Thank you all for being here. Hello and welcome. I'm your host, Stefan Burns, geologist, geophysicist, space weather guy, cosmic bro, just really trying to understand what's happening on our planet. And so we look at what's happening geophysically and geologically here on Earth. That's earthquakes, volcanoes, geomagnetic storming and severe weather, things like that. But we also look, of course, at what's happening with our sun, our star, because if you don't understand outside the Earth environment, you're not going to understand what's happening here on Earth. You have to go multidisciplinary. So that would be solar activity, space weather, solar cycles. We look at planetary resonances, some incredible planetary resonances happening right now. And we also look at our interstellar and cosmic environment. As I reported on yesterday, right now there is a giant radio burst coming in from Cygnus X3, the largest since August of 2024. So some really, really powerful energies coming in at this moment in time, all of them converging together. And I mean, maybe I should have gone to sleep last night expecting a Schumann pop to occur because they do seem to always coincide. But well, here we are. It happened, and this is looking really serious. So my base, well, not base case, but I think it's very likely. I think there's a high likelihood, much higher risk than normal, of there being a magnitude 7.5 earthquake that strikes Central Asia. If I had to really, you had to pin me down and say, give me a location, that's what I'm looking at. That's the magnitude time range within the next week. We'll see if I'm right or wrong. I hope I'm wrong. I hope I'm wrong. So let us get into it. There's a lot to cover. Let me show you the latest energy because this already is a couple hours out of date because I created all these graphics and more. So let me show you the latest information coming in from the Space Observing System. We'll talk about the Schumann resonances, a whole bunch of stuff like that. So here we are. This is the Earth Analytics webpage on earthevolution.com. So this is earthevolution.com/energy-analytics. And I have a whole bunch of data feeds here for you. So for example, we can look at the Schumann resonances, 90 days of seismic activity, radiation belts, the aurora forecast. We can look at what's happening on the sun. Big coronal hole on the sun, really large. We'll look at that. I have that up right here, in fact. So we'll check that out, talk about that more. But that is something that's well associated with high magnitude earthquakes, specifically ones for geoeffective in that high speed stream. So that's looking significant. And then sunspot activity is also quite significant. This is the big sunspot group there, 4341, 4343 right here. So a lot of pretty big sunspots. They're not the most massive we've ever seen, but they're significant. This one is kind of actively growing. At least it's maintaining size. It's compact. It's dense. We could see a big flare from that in the next few days. I would not be surprised if we get an X flare from that in the next few days. And just in general, before going on, these sort of sunspots, they emit a lot of high energy flux. We can actually look at it right here. So even if they're not doing huge flares, like big solar flares, there's already more X-ray flux coming off of this, more extreme ultraviolet light flux. Just in general, the light radiation is greater from sunspots because there's more plasma processes unfolding. So the global electric circuit is energizing as a result of that. And if you look at the end, actually, this looks like it's about to go, because you'll see it's really crackling and popping, and kind of just electrical activity is just vibrating there. Just watch the end. So it's really going. Yeah, I would not be surprised if we get something big from that in the next few days or even the next few hours. Once it's going like that, it's usually not that long of a wait. But here we have our Schumann resonances. This is observed out of Tomsk, Russia. And this is effectively a look at the global electric circuit, specific micropulsations in the 0 to 40 hertz range. So we'll talk about the Schumann resonances, what they are. They're Earth's naturally resonant energy fields. And you can measure them in anywhere you want. If you have the equipment, you can measure them anywhere you want. You ideally measure them in a location that does not have a lot of artificial interference, like man-made radiation, cell signals, power grid signals, etc. You see this straight line going across at 20 hertz? That is it's power interference from their 50 hertz power grid, because it creates 10 hertz harmonics, and basically it's noise in the data. So that always shows up. It's this line going across because the power grid's always operating, it's always on. You see that these are very anomalous. The Schumann resonances themselves are these frequencies of light that the Earth generates. Also our brain waves, our heart rhythms have Schumann resonances to them. And they are primarily at 7.8 to 8 hertz, 14 hertz, 20 hertz, 26 hertz, 33, and 39 hertz. So those are the naturally resonant frequencies. What we're seeing here is a huge amount of amplification in non-resonant frequencies. So this is about 18 hertz right there, 17.5 to 18.5 hertz right there. We also see a shadow of it right there in between mode 3 and 4. This is about 21 to 23 hertz or so, maybe 22 hertz. And then we see a huge increase down here as well. This is right near 39 hertz, about 37 to 39 hertz. And you actually see two signals here. So this one right there has this slight concave shape to it like that. And you'll notice that reflection, very faint, but also has that same shape. You will also notice an extremely faint reflection of that right here. Just like that. This then are separate signals. What we see just slightly below that, or a little bit higher in frequency, is a different anomalous signal, though they're coming at the same time, so they're clearly all related. So this is not normal, and we see this sort of activity before high magnitude earthquakes. Let me show you a quick example. We're going to go back to this data I'm about to show you right here, but let me show you specifically what I'm talking about. This is the best example I can show you. That we're going to look at others more recent in time. So you can really get a sense of, hey, this isn't just some made up nonsense, because there's so much of that nowadays on the internet. And most people, to just let you know fully, most people have not read all the research papers that they need to read to understand this. In terms of understanding what the Schumann resonances are, how the Earth creates them, all their different ways of being generated, how they connect in to the global electric circuit, earthquakes, space weather, climate, and more. And then also the pre-earthquake Schumann resonance research is quite a wide body of literature, but most people haven't read it. Most of it's coming out of Japan, but there's also good stuff out of Greece, a little bit out of California with the Loma Prieta quake, some other examples. But if you haven't read it, you're gonna be like, oh, this is nonsense. But if you read the like 3 dozen papers just on that, or like the 6 dozen overall, right, then it starts to make sense. So here we have pre-earthquake signals that appeared 4 days before that magnitude 7.8 and 7.5 earthquake that struck Turkey. That was with the full moon on February 6, 2023. And I have my own personal story there because I was nearby in Aswan, Egypt, and I had these crazy feverish symptoms at night the moment that earthquake struck, and then they went away after the earthquake finished. So I wasn't super close, but I also wasn't super far away. It's about 1,400 kilometers away, maybe it's like 1,000 kilometers away. Egypt and Turkey are fairly close together. So I know that there was something weird happening there. I noticed these signals 4 days before. I was at the pyramids at that time, and I was wondering, like, what the heck are these? Because at that moment in time, I was doing the research into pre-earthquake signals, but I'd never seen them in the wild. So I kind of logged it away. You'll notice here we have something called our Q factor, or you can also call it qualities. And this is a measure of what's called resonance amplification. And so what is resonance? Resonance is when two things are at the same frequency, and there can be an energy and information exchange between them. So you have a tuning fork, let's say 200 hertz, you hit it. You have another tuning fork, 195 hertz. It's not going to start vibrating. The 195 is not going to start vibrating with the 200 because they're different frequencies. But if I take two 200 hertz tuning forks and I hit one of them, so now there's this energy in it, it's vibrating. I put them really close together. Everyone knows this, right? The other one will pick up some of that energy and then they'll both vibrate. That's an example of resonance. Or another classic example is like metronomes. You'll take, let's say, 4 metronomes, like the classic ones that go like this. You set them all to 60 beats per second, and then you have another one, and the one that's off will enter into resonance with the others, the other 4, because there's more energy there. So they all then enter into resonance together. That's an example of resonance. Resonance amplification is a measure of the energy going into a resonance system and the energy leaving it. Because in the example of a tuning fork, you hit it, it vibrates. How much that energy is dissipating over how long of a time period, right? And are you continuing to hit it? Is there some way for you to keep that tuning fork vibrating? A classic example would be the Tacoma Narrows Bridge in Washington. They built this bridge, and then the winds going through that valley were such that they resonated with the bridge. So they call it galloping Gertie, and it would go like this, and one day it just completely collapsed because it just specifically was at that resonance. And so the energy going into the bridge from the wind was continuous. The amount of energy leaving the system through dissipation, friction, whatever, was less than the energy coming in. So the resonance got bigger and bigger and bigger, and then it collapsed. So we can also have that dynamic with Earth systems where you get this resonance amplification of energy going in, but energy not leaving. We measure this with Q factor. This is one of the key factors as it relates to pre-earthquake signals and knowing that we have good signals or not. And by good, I mean like legitimate, like this is something we need to pay attention to. We see here 4 days before this magnitude 7.8 earthquake, check out exactly when that happened and the energy signature that we got in the Schumann resonances for, what was that, about 8 hours afterwards? About 8 hours afterwards. I think it's more like 9 perhaps. Check that out. Very similar in shape and structure. If we go back to what's happening right now, you see how they look very similar. Not identical, but very, very similar. Let's go back. So Q factor is measuring this resonance amplification. Normal values are around 10 to 20. We see that here with mode 1, mode 2. Mode 1, 7.8 hertz, mode 2, 14 hertz. Mode 3 and mode 4 in this pre-earthquake signal range. Because the frequency range for pre-earthquake signals in the Schumann resonances, there's other pre-earthquake signals too, and extremely low frequency in other zones. is about 20 to 30 hertz. If you really had to expand out the zone, it's about 15 to 35 hertz. But really it's actually mode 4, 25, 26 hertz that you really specifically see them, but in general, 15 to 35 hertz, more selectively 20 to 30 hertz. You see that mode 2 here went up to 250, so mode 3 went to 250, mode 4 went to 59. So this is 20 hertz, this is 26 hertz. They both saw this increase of their Q factor. Mode 4 here going up about 3 times higher than the maximum range that it normally reaches. Mode 3 going up to 290, which is a dramatic increase. That's what's happening right now. We can look at that right here with our data. And so here we see our energies coming in now for more than 12 hours. Again, we have 2 new hours there. We looked at the very beginning. We'll look at that again. But we see here our Q factor. And so Q factor for mode 4 is looking normal because we don't see any crazy energy bursts here. I mean, just a shadow of it in between modes 3 and 4. But it looks fairly normal in mode 4. But there is mode 3. Check it out. Q factor 310. And this is not an abnormal, like we saw this spike in June. That was a data glitch. It is interesting. This is June 2025. It is interesting that occurred, and we had the megaquake in July. So it's just kind of a weird timing sequence. There's a whole bunch of weird things that pop up with Schumann resonances where sometimes you can't necessarily like scientifically pin it, but it still lines up and like is an explanation. It's this weird metaphysical vortex. That's the best way I can explain it. You have to suspend the left side of your brain a little bit if you're going to understand these things, because they are very informative and they connect into all these different dimensions of reality, not just the material. So it gets kind of wild. And our brain waves have the same frequency as Schumann resonances, the same power, which means that we can enter into resonance with them. And therefore, when there's this resonance amplification occurring, what's that doing to us? Biologically, consciously, and more. That's a whole separate video. We can go into that in the Q&A perhaps. But we can see that this spiked up to 310. Again, right there's the Q factor, 310, making everything else look like a flat line because it's just all been squashed down in terms of the scale now, just dramatically going up. And you see that this perfectly lines up with these signals coming in. So this right there specifically for right here. If we go to the next slide, you'll see what I'm talking about. Here, I have the Q factor, highlighted. We see it going up. We see that our amplitude for this went up as well around this time period, making all the prior amplitude variations look pretty minor. And we see our frequency drop significantly here. So you'll see that our frequency range is 20.8 hertz going down to 17.9 hertz, which is well outside of mode 3. Mode 3 is right on 20 hertz. It's about 20.1 hertz. So for this to drop down to under 18 hertz shows that this is a very anomalous signal. And that's exactly what we have right now. Let's go back to our recent data. So we can get that right here. And let's refresh this to get the absolute latest for all of you. We have a lot of stuff to talk about today, but this is coming in right now, like right now. So this could be, there's a few possibilities before we go further. First possibility is that nothing happens. That's what we hope for. Nothing happens. It's hard to put a percentage on that. I wouldn't say it's 50% or more. I think it's more likely that we get a big earthquake, because just having tracked this across time, when we get energy signals that look like this, there's differences to these things. Sometimes they're kind of more minor, sometimes they're bigger, but when they look like this, I'm thinking magnitude 7.5 or greater. And we've actually been talking about this time period for a high magnitude earthquake due to other factors. This is now like the final confirmation that we got something coming, effectively. So I think the nothing happens scenario is maybe 30, 20, 20%, something like that. It's not the highest by my estimate, right? By my analysis. Who am I? I'm just a guy on YouTube, right? Do your own research, but do the research. Read the 6 dozen research papers if you want and more, and track it every day, right? There's something to be said about actually watching this stuff daily with the understanding of what it is that you're looking at. That's the best way to learn. Anyways, so the second scenario is that we get something like really soon, within the next week. And that would be a high magnitude 7+ earthquake. If this is for a lesser magnitude earthquake, magnitude 6 to 7 in that range, then it would be very close to the epicenter. Because what happens is that these earthquakes that produce these sort of signals, they're often big. But where you measure them matters because the signals attenuate as they propagate out. So if you're right over the observation, like the epicenter, the observation station is effectively right over the hypocenter of that earthquake, you're going to get those signals as strong as possible. If you're 3,000 kilometers away, they're going to be reduced in strength. So big earthquakes can generate larger signals that are picked up more globally, you could say, whereas smaller earthquakes can still get picked up if they emit these in the first place, if the observation station coincidentally happens to be nearby. So the fact that these are quite large expands A, the radius of where this is coming from, and or B, the magnitude of the quake. I think this is looking like a magnitude 7 or greater. I'd really have to say probably magnitude 7.5 or greater. I'm thinking Central Asia. We'll talk about why. So that could, possibility B is that that occurs within the next week. I think that's the highest likelihood. I put that probably at 50%. Nothing happens, 20%, this big magnitude 7, 7.5 or greater in the next week, 50%. Option 3 is that this is delayed and these are pre-earthquake signals that are actually pretty early and in advance of the big earthquake. So we could be looking at something within the next month. I'd say that's probably a 20% chance. When we start to get them looking like this, it's often coming in less than a week. As we saw with Turkey, that was less than a week. It was 4 days before the big earthquakes. And we have another example I can show you from California. This is interesting. So here we can check that out. Here we have some pre-earthquake signals out of California. This was November 28th, 29th of 2024. And you see how they're very similar. They have these reflections across the frequencies going up in frequency. They're very clearly not normal Schumann resonances. They are anomalies within this frequency range. And something to keep in mind is that a lot of this is more than just Schumann resonances. Often with earthquakes, we see ionospheric anomalies before, during, and after. So there's changes to the upper atmosphere of the Earth, which is very conductive. Basically showing that there's a change to some electric circuit dynamics of the Earth occurring with an earthquake. Remember, very powerful earthquakes, magnitude 7, magnitude 8, magnitude 9, these are like massive explosions, right? Like huge explosions beyond anything that we have the ability to manufacture as far as we know. So like ginormous. So it makes sense that such a massive amount of energy and there's plasma involved with this is going to alter electric circuit dynamics. And as I was talking to Frank Hugerbeets in my interview with him, my conversation podcast, right, about 2 weeks ago now, the earthquake isn't necessarily starting the moment you have that rupture and the ground starts to shake. The earthquake can actually begin much earlier. It's just the final climax moment is the actual rupture, the fault slip, the shaking. But there are dynamics that unfold that are the earthquake, like we saw in Turkey 4 days before we had these signals. So the earthquake had already started. It's just it hadn't reached its crescendo climax yet. So this was end of November 2024. And guess what? We saw a magnitude 7 earthquake strike off the coast of California on December 5th of 2024. It was either the 4th or the 5th of December. So that's a big magnitude 7. We just had a magnitude 6 off the coast of Oregon, right near that triple junction, just slightly to the north. We'll check that out. But so that's California is kind of number 2 on the list in terms of a high magnitude earthquake occurring because of these signals. Because we have a clear example where less than a week after we got these signals out of Tomsk, we had the largest earthquake of the recent time period in California. So I think they're connected together because these are very unusual. Lasting for about 12 hours, that's not normal, and well, we had that earthquake. So California is also, you could say, on the firing line, especially now that we just had that magnitude 6 to the north in Oregon, which just loaded more energy onto all the faults in California. And we can see here with this example, the Q factor also spiked up dramatically. Specifically, again, mode 3 is often the biggest one, 190 here for mode 3, 20 hertz. But we see that mode 2 at 14 hertz went up to 120. Mode 4 at about 26 hertz went up to 48, just with a few of these spikes. But it's really mode 3 that spiked up the most. So Q factor is really a key thing to look at, because if you're just looking at these signals but you're not looking at Q factor, you know, we sometimes see weird things in the Schumann resonances that don't elevate the Q factor. It's when you get the two of them that it's like, hey guys, red alert, this is the time is now. That's kind of my thought process there. Let us look at earthquake activity right now. And we'll pull this up. Here we have our earthquakes for the past month, magnitude 2.5 or greater. Here we see this magnitude 6 off the coast of Oregon, fairly close to axial seamount, which is just right up in this area here. And this is close enough to California to effective. And we also remember we had the 6.5 in Acapulco. Recently. We can also see that one here. If we go to the largest magnitude, this will pop up a little bit better, put them on the map, right? Here is our 6.5 Acapulco. Here's our magnitude 6 Oregon. And then in the past couple months, we've had the magnitude 7 earthquake up here, Hubbard Glacier. That's just slightly outside this time frame because that was back in December, I believe. I mean, we can expand this time frame out a little bit. We can go back to, oh, that's only the past 7 days we're looking at, I think. Let's go back to November, all right? Let's put a 4.5 or greater on here. Let's actually put magnitude 6 or greater. That should, let's see what went wrong. Oh, 2026, that would do it. So here we are, and we can give this a look. So this is the earthquake activity that we've had around North America. 6.2 Peru, 6.5 in Mexico, 6.0 in Oregon, magnitude 7 in Alaska, and also we do have this magnitude 6 that struck just outside Anchorage. That was also in November. Hubbard Glacier was December 6th, so just a little bit more than a month ago. Well, if you look here, where's the one zone that really hasn't had one, right? California. I mean, that magnitude 6 is getting close to it. Maybe that's it. I don't like to say it. I love California, right? It's where I grew up, but California is looking like it's on the firing line, honestly. So that's another location. But we will talk about that more a little bit later. One important thing that you may be thinking of is like, okay, well, are we seeing this signal elsewhere? So let me show you, and actually, yeah, let me set this back up for significant worldwide. Here we go. I want to show you this. So where are we getting this data? This data is coming to us from the Space Observing System out of Tomsk, Russia. And we see Tomsk right here. So there it is. This is the city of Tomsk, Russia. And you'll notice that it's basically close to Mongolia and Kazakhstan, just to the north. And it's not that far away from Central Asia. So it's actually quite close. And here we have all the stands: Kyrgyzstan, Uzbekistan, Tajikistan. I think there's some more stands. Well, of course, there's Afghanistan, Pakistan, right? Turkmenistan. Yeah. But if we look here, we see that there's a whole bunch of distributed magnitude 5 activity here. So 5.3, 5.3, 5.3, 5.2, 5.0. Quite a lot, showing that overall strain in this location due to larger plate tectonic forces is increasing. And there's some release of that with these magnitude 5s. These aren't big earthquakes. If you were to get a magnitude 7.5, that's 100 times more energy release than a magnitude 5.5, for example, which we have even had here. So this is quite significant. Because Tomsk is so close to this location, that could explain why these energy signals are coming in so clearly. Now we do have other observation stations in Italy. We have VLF.IT out of Cumiana, Italy. There's a guy there who runs it, and he posted data online. Different setups, which give you kind of different energy signatures. We also have data out of Sopron, Hungary. They have great chocolate there, by the way, if you haven't been. I actually went and visited this Schumann Resonance Observatory, met the head geophysicist. He's a pretty cool guy. They have an observatory, and we do have some observatories. Like we have one in California, but there's like a time delay on it. Sometimes you don't get the data. One for New Zealand, one also for Lithuania, and there's a variety, but there's not that many public data feeds. So with that said, we can look at our data for Cumiana, Italy, and we don't see anything coming in. Now this is not uncommon. There seems to be something special about the location in Tomsk, Russia, because it's right in the middle of the Eurasian continent. Seems to make a difference as it relates to being able to pick up these pre-earthquake signals. We have seen unusual signals out of Cumiana, Italy before, specifically before the seismic burst in February in 2025 at Campi Flegrei. We saw a whole bunch of weird fluctuations in there. We were talking about that. So it can pick up, but that's a more local feature. Campi Flegrei in Italy, not that far away from Cumiana, Italy, of course. It's not picking up any signals that, like we're seeing right now, the space observing system. Does not mean that this isn't significant. Same deal also with Hungary. Their data feed is in general lower resolution. They have their magnetic field components and also their vertical electric field. We're not seeing any abnormalities there. I mean, a bit of noise right here. It is a little odd. That's mostly in mode 1. Let's see, maybe it's snowing there. They have a weather feed as well. So let's see what's happening here to explain that. But we're not seeing those like parabolas, right? So that's kind of the hyperbolas rather. So we're not seeing that. And if we look at their weather data, it looks like there's been some fog and drifting snow, just some minor stuff, though that does line up with those time periods here. So that's probably weather-based activity. In general, again, we're not seeing those clear hyperbola structures like we're seeing out of Tomsk, Russia here. So just because we're not seeing them doesn't mean that those, like here, doesn't mean that they're not relevant signals. It just means that what we get in Tomsk specifically, it's a good location for this, and B, it's probably fairly close to the location of the earthquake if one is to occur. The larger it is, the further out it can be. We did see those earthquake signals that were anomalous from Tomsk just less than a week before the magnitude 7 in California. That's pretty far apart, so that's pretty wild. I was surprised by that. I was thinking when I saw those signals out of Tomsk back in November 24, I was thinking that it was going to be something more in this region. California was the one that did it. So it doesn't necessarily have to be close by. But if I had to assign probabilities, I would say Central Asia is top right now because this is just showing overall stress dynamics unfolding with the movement of the Indian subcontinent into Eurasia, and that we can get big magnitude 8 earthquakes from the Himalayas and in this region. Big ones. I'm talking big earthquakes. We can look at the record. Maybe we'll see some. We'll check that out. And this is close by, so that would explain it. We also have been seeing tons of activity out of Japan. Magnitude 7.6, magnitude 6.7, and a bunch of magnitude 6 earthquakes. There was a 6.8, 6.4, 6.6, 6.0s, 5s. So Japan has also been very active. It is one of the most active places seismically in the world. But in general, it's been more active than normal, and this could be activity before something even larger, magnitude 8 or greater. You know, the moment you have a magnitude 8 earthquake, that 7.6 is teeny tiny in terms of the energy release. So if we're talking about Japan, the most likely zone would be right into here. This is where all the earthquake activity for the most part has been happening. Also this cluster up there. If you had to expand it out, I'd say this zone right there, but really specifically, if we get a big earthquake in Japan, and this is a signal foretelling that, this would be the zone that's likely to occur. And I would say Japan is magnitude 7.5 or greater. We didn't see signals like this with the 7.6. And Japan often we don't see these signals before earthquakes in Japan because of the ocean there absorbing the signals. So I think I mentioned that, but a key factor is that it's a land-based earthquake. Because the ground overall, yes, there's conductivity to the ground, but compared to the seawater, it's like 7 orders of magnitude less conductive or more resistive. And so those signals can propagate out and then immediately hit the atmosphere where they have very little attenuation in the air, right? So land-based earthquakes really seem to be the ones that generate these intense anomalous signals. For example, with Turkey, we had that 7.8, 7.5 near Gaziantep, border of Syria, right? We picked those signals up. Well, guess what? This is land-based. So, makes sense. So that's another clue, is that in general, you're looking more likely at a land-based earthquake, not a ocean-based earthquake. I say it's probably 80% chance that's land-based and not ocean-based. So for California, if that's also location, then we're looking somewhere in here on the San Andreas. Either the southern section, northern section, they both had a lot of built-up strain where the San Andreas bends is where you get these big earthquakes. Doesn't have to be right at the bend, but that's why they generate big magnitude 7, 7.5, even magnitude 8 earthquakes. We have the other bend up there. So California also is a location. And normally I would be like, California is too far away for these signals to be relevant, but we saw with 2024 how that was the case. So I don't think we can cross it off just because it's far away. But primary location would be Central Asia. Let me show you a few more examples of this stuff. Then we're going to talk a little bit more about Schumann resonances, kind of what they are and everything. Here we see some anomalous signals from May. We didn't have an immediate result in terms of like a big earthquake after this, like in the days following. But they were strange, and they're kind of not the most obvious and definitely not as clear as we have right now. Oh yeah, moderators, just ban whoever you need to ban. If anyone's being an asshole in the chat, just cut them out. All right, I wouldn't mess with it, so you don't have to mess with it, okay? So we see right here, we're not fooling around anymore, folks. This is like the real deal right now. So we see these signals here, but they don't really show up clearly all the way across, but we do see the overall shape and structure, all right? We also see them over here. So this was a highlight that I did, like, okay, we have some pre-earthquake signals. Nothing immediately resulted from this afterwards, but look, May 11th, 2025, July 29th of that year was the magnitude 8.8 megaquake. And so when I was getting ready for this video, I was looking at past examples and I saw these. It's like, that probably was like a way early leading indicator for that megaquake. Because these were bizarre. We didn't have an explanation for them. And while I didn't know what was going to happen in 2 months. So it took 2 months, but eventually we had the big magnitude 8.8. First big earthquake like that since 2011. So one of the largest earthquakes ever. So it makes sense that with one of the largest earthquakes ever that we would see signals even further in advance. That's also another relationship. The bigger the earthquake, the earlier in time these sort of signals can be picked up. So I think that's and then we have this example right here. This was an anomalous burst at 25 hertz that we had just last month. And this was right during the perihelion of 3I Atlas, which is quite odd. And while we saw a whole bunch of earthquake activity occur right around this time frame. Specifically, I think it's Acapulco that occurred just before, and then Indonesia or the Philippines right afterwards. Let's give it a look. So we can set this for largest magnitude. And we want to turn that off. So that was on the 19th of December. And we see here, let's go back far enough. Papua New Guinea was on the 22nd, 6.5. And if we look, that was a land-based earthquake in Papua New Guinea, 6.5. And then where is the Acapulco? Maybe it's slightly further back. I think Mexico was actually just before that signal. It was like the 14th of December, perhaps. I could expand out this time frame, but we could Might as well expand it out to just the beginning of December here. So let's do that. We'll go. Oh, is this already set for, okay. Yeah, here we go. This is better. So Acapulco, Mexico, coming in right here. And that was on the, wait. Oh, that's January. I'm thinking of, what was it that occurred right around this time frame? Let me set this to newest first and go back to the 19th of December. There's so many earthquakes, it's hard to keep track of all of them. You know, I wish I was able to precisely. Here we see, yeah, the 6.5, Papua New Guinea. We had the 6.7, Japan, a few days before the 19th, about a week before the 19th. So that 6.5 is probably what that was related to. It's also interesting, the connection with 3i Atlas. Again, as I mentioned earlier, kind of have to expand out just a little bit for this to make sense after you've done all the research, but there are some interesting connections. So let's just quickly talk about what the Schumann resonances are. This will be helpful. We'll also talk about the global electric circuit, and then we'll get to our question and answer. We'll look at this data one more time as well, but let's talk about the Schumann resonances, what they are. If you're wondering what the heck these things are the whole time, we'll get into it. Okay, so if you are new to this subject, what are the Schumann resonances? The Schumann resonances are these energy fields that exist on Earth, and they are energies that are naturally resonant with the planet, because we have our Earth, and there's a physical size to our planet. The circumference is about 40,000 kilometers. If you have a larger planet, smaller planet, changes some of the dimensions and the factors involved. Well, at 40,000 kilometers, you can take the speed of light, which is 300,000 kilometers per second, and you can do some very simple math, and you arrive at a frequency of 7.5 hertz. So if you take 300,000 divided by 40,000, you get 7.5. 7.5 hertz is right at that foundational mode of the Schumann resonances. The idea, and what we know, is that the surface of the Earth is in general conductive. It's 10 to the negative 7 Siemens, S-E-I-M-E-N-S. It's a measure of conductivity named after some German guy. Okay? You know, Siemens Company or Siemens Corp, whatever it's called, Germany. 10 to the negative 7 is the conductivity of the ground, though in certain geologic layers it's higher or lower. In general, it's around there, okay? The ionosphere, the uppermost part of the atmosphere, denoted by this kind of zapping electrical layer there, its conductivity is also 10 to the negative 7, roughly. Its conductivity increases as you go further out. The atmosphere in between, specifically the lower part of the atmosphere, the troposphere where we live, and even more specifically the boundary layer going from 0 to 2 kilometers, is very resistive. 7 orders of magnitude more resistive, so 10 to the negative 14 Siemens. So as a result of that, you have a conductive waveguide, where you have conductivity here, conductivity there, a lot of resistivity in between. When you have a magnetic signal, a magnetic field, magnetic wave, whatever, it will get absorbed into anything that's conductive. So something needs to be resistive for it to nicely travel through it. So if you have very resistive rock and there's some subsurface electromagnetic thing occurring, you could get those signals to go through that rock because it's not going to absorb that much of the signal. Whereas if all of a sudden you have this super extensive water table that's filled with brine and salt and it's very conductive, or for example the ocean, it will absorb those signals before it reaches the surface because the magnetic field is absorbed into a conductive medium. So we get these energies to naturally propagate around the Earth, and they are low enough frequency that they don't attenuate that quickly. So we see all these lightning strikes occurring here. There's about 50 lightning strikes on the planet every single moment, so 50 per second. And as a result, they produce radiation across the entire light spectrum, going from very extremely low frequencies near 0 hertz, all the way through the radio frequency spectrum, like kilohertz, megahertz, gigahertz, terahertz, where we see visible light, and then going into ultraviolet, extreme ultraviolet, X-ray radiation, and also even sometimes gamma rays. Really powerful lightning strikes can produce gamma rays, but they'll get absorbed into the atmosphere very quickly. The higher the frequency, the more easily it's absorbed into the atmosphere. The super, super, super low frequency stuff, though, is not easily absorbed because absorption is based off of the cycle rate, the frequency. So the more chances, it has more chances to interact probabilistically with some sort of molecule or atom, like an electron, for example, a particle, every single time it cycles. It's a quantum thing. So if it's only cycling 8 times a second, it's a lot less likely to interact with something than something that's cycling, 8 billion times per second. So as a result, these Schumann resonances, they have these wavelengths that are either the same as the circumference of the Earth, that's the foundational mode, 7.5 to about 8.5 hertz, or they are harmonics of that, higher modes like mode 2, mode 3, mode 4, which are also resonant with these physical dimensions. And because we have an active global electric circuit and this flow of energy, we are producing these sort of frequencies all the time. You also get Schumann resonances produced by the sun hitting and ionizing the atmosphere. Every single, it's happening all the time. There's always a part of the Earth that's facing the sun, that's on the sunlit side. And that's called during ionospheric sunrise, when the Earth rotates into view of the sun, that new part of the Earth, and it all of a sudden ionizes, that releases Schumann resonances. We see them also produced in a variety of other ways. For example, these pre-earthquake signals, our brain waves. There's space weather factors as it relates to Schumann resonances as well. You can have these frequencies embedded within the solar wind, and when those reach the Earth, they just get injected right into the resonance system. That's pretty rare, but that is possible. And there's some evidence that we've been able to pinpoint that's the case at times. So that's the Schumann resonances are shown by this glowing network there, and we're seeing 3 colors, which basically signify the 3 main modes. We also, of course, have a magnetic field to the Earth, so we're seeing that flow of energy with the magnetic field, and it's a very complex system, but it's very active, it's very alive, it's always going. They're always resonating. They don't stop. They don't just turn off and then turn back on. It's just always active. There are certain parts of the globe that are very active. They're called lightning chimneys. We can look at this graphic here. The main lightning chimneys are Southeast Asia, Africa, and the Americas, specifically around like Colombia, Venezuela, the Amazon rainforest, but also that includes Texas, Florida, the Caribbean. Gets a lot of lightning activity. These lightning chimneys, as they call them, produce a majority of the lightning strikes on the globe, and they have their greatest activity typically around sunset local time. So we'll get these bursts of activity in the Schumann resonances at distinct times every single day as a result of that activity. Of course, there's changes based off of the season, whether it's winter or summer. There's also changes based off of the solar cycle. There's a whole bunch of connections with Schumann resonances. They become more likely as the Earth warms up because there's more energy, more lightning strikes. Some estimates are that lightning strike activity is going to increase 20-fold if there's a 2-degree global increase in warming. So think about what's happening right now energetically. Think about what's going to happen if we have that occur. And that is the case, where now all of a sudden we have 20 times more lightning strikes. Things are going to be wild. Bigger earthquakes, more frequent, more storms, all of that. Like, it's going to be insane. I think that's where we're going. I think Earth is becoming more of a storm world. I'm just one guy. That's what I think. I'm pretty good with being able to see kind of what's going into the future a little bit. A lot of people say that one of the best measures of intelligence is your ability to predict the future. Elon Musk is a big fan of that. And, he thinks that AI is going to be able to tell you the future. It's not, no. It's more than that. We have to tap into realms beyond the material. And if you do it, and you have a good kind of intuition and sense of foresight, some people have these gifts, you can kind of see what's coming up. So I don't say I know everything, but having studied this, seen the trajectory, I think that's the direction we're going with the Earth. So these sort of events are going to probably become more common. And that's just part of the ascension evolution of the Earth and therefore of ourselves. That's just the path that's been charted for us according to the will of God and the consciousness of the universe, our solar system, the sun, and more. This is what Earth wants, I guess. That's kind of my intuition there. We have So there's a lot with the Schumann resonances, and they're a very important part of the global electric circuit. Let's talk about that. Here we have a diagram showing various components of the global electric circuit. So we have kind of this overview diagram here where we see the surface, we see the layer in between. This is the atmosphere, and then up here we have our ionosphere, and we have these electric currents in the ionosphere. There's in general an electric field potential of the ionosphere. We call it an equipotential because in general the field voltage is equivalent all across the ionosphere, though there are variations that exist in the northern and southern hemispheres, specifically like near the Arctic Circle, the polar cusp where the magnetic field comes in. The equipotential will go up, sometimes even like 50, 60, 100% in strength. But the overall equipotential typically about 250,000 volts or 250 kilovolts. Earth's surface has a potential of about 0. So now you have this gradient in between them. As a result of that, and here in this graphic they're showing 400,000 volts. So as a result of this gradient, you get this current flow that come down. It's pretty weak. You see here it's only 10 to the negative 12 amps per square meter. These graphics come from Feynman, the famous physicist, but we do have that current flowing. If you're measuring the Schumann resonances in the vertical electric field, that's what you're measuring them on. If you're measuring them in the magnetic field, then you're measuring them in the magnetic field, either north-south component, east-west, any direction you want, you can do it. But vertically, we have this current flowing from the ground surface to the ionosphere, bidirectional depending on the charge. So these antennas are strung up to connect to that, and then these tiny little oscillations jiggle electrons in the antenna, which then we take and transform into the spectrograms that we were looking at earlier and we'll look at again. This is a very weak current, but when there's changes to this larger system, we see increases in specific frequencies of the Schumann resonance or resonances. For example, these anomalies. Here we see the atmospheric vertical electric field, and you can see that it increases pretty quickly, 100 volts, 200 volts, 300 volts, because it has to get to 250,000 volts. So there's actually a really strong electric field gradient going up. You know, the wall plugs in the United States run at 120 volts. In Europe, it's 220, something like that. So that's enough to run an appliance on. Now, current is what matters as well, but there's quite a bit of potential there. Thankfully, we're not zapped all the time because A, the atmosphere is very resistive. Does not mean it doesn't affect us though. When there are changes to our electric field dynamics, even though the atmosphere is very resistive, it's not causing us to get shocked all the time, doesn't mean it's not affecting our biology. It is, just in more subtle ways. And if you're grounding, bare feet on ground, then this equipotential will actually, these potential lines will actually flow around you because you carry that 0 volt potential up to your height, which let's say is 6 feet, which is what I am. So we see that dynamic at play. Now, here's something that's important to know. If you have weather activity in the local boundary layer, right? You know, thunderclouds, there's a rainstorm, it's snowing, something like that. The electric charge potentials in these cloud systems can get huge, especially for like big systems like cyclones, hurricanes, typhoons, massive, massive, massive amounts of charge going into the megavolt range. So you can have positive 100 megavolts. Negative 100 megavolts, that's 100 million volts, way higher than here. As a result of that, you now can imagine that electric current going in between is greatly amplified. Still weak compared to, let's say, the current in your wall, which is driving your toaster oven, but it's quite a bit stronger than just this one here because this difference is 250 kV. This here is 100 MV. So big difference. That affects the Schumann resonances and other atmospheric electrical dynamics locally. And those lightning strikes, you know, some of that energy does bleed out and become the global Schumann resonance signal. So it's really complicated stuff. I do my best to keep it as simple as possible. We see diurnal variations to the Schumann resonances across the seasons. Here we see Schumann resonance at 8 hertz. It spikes up in the morning. This is local time. Here, we see it really spike up later. That's because of often the lightning chimney dynamics. And then we see how this changes across the seasons. So there's a lot of variation to this, but the key is to watch this stuff fairly frequently in terms of just you have to get your eyes on the data all the time, and then if you see these anomalous signals come in, you know you got something really cooking. So this is our latest refresh right now. This signal is still continuing. Now it has been, if we take this back to 11:30 here, it's been 12, 15 and a half hours now of anomalous signals. So I'm not going to be surprised at all if we get a big magnitude 7, magnitude 7.5, even magnitude 8 earthquake in the next week. We'll do a video on it, right? People will be able to point at this and be like, yo, our boy Stefan, he called it again. Not guaranteed to happen, but I'm not going to be surprised now. Now that we've seen this and everything else at play, let's talk about some of those other factors. Well, let's look at our coronagraph view. This is what's happening right now with our sun. And we'll talk about also that coronal hole. So we have a huge congregation of planets right now around the sun on the other side. We have Mercury right there. That's Mars. This is Venus. Venus performed her superior conjunction with the sun around the 6th of January, 6th, 7th, right around there. There was a Mars-Venus conjunction, I believe on the 8th, but 7th, 8th or so of January, and then Mars did its cazimi, its superior conjunction around the 9th of January. Mercury then swung in really quick. It's moving very quickly, the fastest of the lot, and it's going to do its superior conjunction right around the 19th of January. It's the 17th right now. We have the new moon on the 18th. So in just one day, the moon, being the fastest from our perspective, is going to really swing in here like this, all of a sudden be there as well. And Pluto is way off in the distance, but it's also right in this location. So we've been talking about this. Guess what? Jupiter is right behind us in opposition to all this. So if we're looking at the sun, we're seeing the sun like this. The sun's right in front of us. On the other side are the planets, and then right behind us is Jupiter. It's really a rare planetary alignment. And we get these sort of big earthquakes around significant planetary alignments like this. We've been talking about this. Mercury is seen as the activator. So if you had to really put a pinpoint date on this, not saying this is the case, Earth is much more complex and nuanced. And it's hard to really get the exact perfect forecast, though it's been done. We've done it before with the megaquake 3 days before it occurred, Kamchatka. We called it on the channel. The evidence, the receipts are in the videos. You can watch them. I've talked about that a lot. You guys all know if you've been here since then. It was crazy. Around that superior conjunction, perhaps, is when we see that occur, or this occur, whatever. It's all possible. The big sunspot will be Earth-facing. It doesn't even have to give us a solar storm. Maybe it's just enough of a charging influence on the global electric circuit to make this all pop off, and the big, the something big that happened is the earthquake, and not some geostorm. A big earthquake is much more of something that affects us much more in a real way than a solar storm impact. You need a Carrington event or a super flare to really cause something that affects everyone globally. But a big earthquake under, let's say, Islamabad, let's say like a magnitude 7.5 under Islamabad, that would not be good. We hope that doesn't happen. Or like another magnitude 8+ earthquake Japan with the tsunami. We don't want that to happen, but these are real things that have much more effect than, oh, we see the aurora because we had a G3 storm. That can cause some satellite issues, maybe some internet problems, whatever. But in general, the effects are pretty low. If we're talking something really big, though, we're talking big volcanic eruptions, like volcanic winter, like it creates a volcanic winter, or like big earthquakes. So we can load in Stellarium. I want to show you this as well. Let's check out Stellarium really quick. And we'll see these planets all congregating together in time. It's really quite wild what's happening right now. You don't see this every day, effectively. This is a pretty historic moment, I would say, that we're living in right now. We'll turn our constellations on. We'll turn our ground surface off. We'll put on our ecliptic plane here. And just immediately, we can see here Venus, the Sun, Mars, Mercury, right? Mercury is going ahead like this. If I go forward in time, you'll see what I'm talking about. First, let's do it by day first. Right here, you saw Mercury shift. If I do that again, Let me kind of go up for you like this. If I go forward again, see how Mercury shifted past Mars? So Mercury is going forward. We have that superior conjunction around the 20th, 21st of January. But here is our new moon right there. There's our new moon. And let us do a search for our favorite dwarf planet, Pluto. Oh, look, Pluto's right there. What up, Pluto? So we can tag this as a marker. I don't know why they don't label the planets more obviously in Stellarium. They do it based off apparent magnitude, but they're kind of losing the point of the plot if they're not putting markers on the planets like Pluto and Neptune just because they're not that bright in the sky compared to, let's say, the sun or whatever. But I digress. And then right on the other side of the Earth, we have Jupiter here in the constellation of Gemini, the twins, Pollux and Castor, which are the two main twins known from, the myth of the Spartan queen Leda and Zeus, who impregnated her as a swan. And we just had the Cygnus X3 giant radio burst that's happening right now in Cygnus, the swan constellation. And it's Jupiter opposition. Jupiter is at its brightest. It's at its closest to Earth. You can't make this stuff up. The connections are just crazy. You just have to have an ounce of awareness and a bit of an understanding and knowledge of history and myth, and it jumps out at you. So it's not like the universe is keeping this a secret, folks. At least I don't think it is. So yeah, I mean, just look at that. If we zoom out, this is what we have happening right now: Sun, Mars, Mercury, Venus, the Moon, and also Pluto. Big congregation. Really big congregation happening right now. And to finish, here is our sun for the past 48 hours. We see this massive coronal hole on the Earth-facing side of the sun, and these are well connected to high magnitude earthquakes. Specifically, when we're connected to their high-speed stream and the solar wind density drops significantly, that's when we get the boom shakalakas. So this is about to connect to Earth. We see it's trans-equatorial, it's big, it's wide, so we're going to be embedded in that high-speed stream for a while. This is not going to be some quick thing. It's going to take some time for us to get through that. As a result, we're likely to have that solar wind density drop quite a bit. This is something to be aware of, and it's not a nothing. We can look at our space weather model here by NOAA, and we see this high-speed stream. Get that loaded up. So we have the plasma wall at the front of it called the co-rotating interaction region sweeping by the Earth right there. Plasma density goes up, followed by an increase in the velocity. Right here, they show that coming in around the 20th of December. And then we're in this high-speed stream. Check out the velocity there. It's a big, wide, high-speed stream. Density will get very low. Here we have our density. Drops off significantly, as you can see. And that's all happening around that new moon. The new moon's going to come in, and then we're going to have that Mercury superior conjunction right around the time that this connects. If I really had to pin it down, I would say that's the time period. January 20th to 23rd is when things are looking really dynamic. That will be the 20th of January is Tuesday to Friday. Tuesday to Friday of next week, I would say, is like the big time period. It could occur before that, after that. It's hard to get exact pinpoint, to the minute. But that's the highest risk time window based off of all these factors. And if that is the case, then what we're seeing here right now are pre-earthquake signals up to a week before it's going to occur. And if we're seeing them this strongly, then it's like, whoa, we got something big coming in. Because again, if we looked at that data, that data from Japan, we can pull it up right here. We had those pre-earthquake signals come in 4 days before, right here. And they were, this is about 7:30 to 1300. So this is, about 6.5 hours, say 6 hours of signal right there. We're already pushing like 14, 15, 16 hours right now. And they're fainter than what we have right now. And that was for a magnitude 7.8 and 7.5 double sequence that hit Turkey. Here's the signal that we saw after that occurred. So We had the earthquake. This is lined up at the time, 1:17 a.m. Universal Time. And we see that we had this high frequency, well, actually low frequency, but we had this burst of energy there lasting for about 6 to 8 hours immediately after that earthquake. And then, of course, there's tons of aftershocks. So crazy stuff, crazy things happening right now. It's good to be aware. It's good to be prepared. That is the name of the game, in my opinion. If we look at our seismic activity, we have been having heightened seismic activity as to what occurred before this 7.6 in Japan. Also this magnitude 7 there. So there's been a lot of activity. And I'm not going to be surprised if we get a seismic burst right here because of the planetary alignment, the space weather factors, this giant radio burst from Cygnus X3. That's adding into this as well. You know, all the collective tension right now and torque and all this that exists in the collective and societally. There's another interesting thing I can show you before we get to our Q&A, is that we had this anomalous energy appear in the Schumann resonances back on the 3rd of January right here. We see this, 2nd of January. This is all UTC plus 7. We did the big strike in Venezuela, the United States did, on the 3rd. And there's reports of them using frequency weapons in Venezuela. And well, the main biologic frequencies to interact with would be brainwaves and everything. So that'd be extremely low frequency warfare. But also they use up to like megahertz, gigahertz stuff. We really don't know. But Havana syndrome has been well documented. Like they are using this technology. So we saw weird signals appear right before the strikes in Venezuela. So it's connected also to other things. There's a lot of people out there that think the earthquakes in Turkey were generated with some sort of earthquake weapon. I don't know. I just know that nearby in Egypt, I was having like crazy out of the blue feverish symptoms, like super nauseous. I didn't throw up or anything, but I was like super nauseous and just like sweating and hot flashes and everything the moment that earthquake occurred, also the few hours before and the few hours afterwards. Because I could barely sleep that night. And we had a trip to Abu Simbel planned. Wake up at 4 a.m. and I was like, I can't make this. Like this is brutal. And the guy's like, get the fuck up. Like you're going. Because we're not going to refund you if you don't. And so I was like, all right, this is too good to pass up. I'll just do my best to survive. And then like a few hours later, I was actually feeling pretty much fine. So it faded really quickly. It was not a normal virus or something like that. It was very bizarre. I think that was the frequencies of either the Earth, or if this earthquake weapon exists, then it was that. I can't say definitively. I think if I had to choose, I would say a natural Earth thing. Because there's other examples of these natural Earth signals causing these sort of biologic responses. I could talk about that. But there's weird stuff that exists on our planet, things that we don't know. And they're not telling us everything, that's for sure. So let us get into our question and answer. And so if you have a question, you can ask it in the chat. Then we'll go through all the questions that pop up as super thanks. I see a few super thanks have come in, so thank you all for that. And one from Ned, do you think global warming is a natural thing, or are we partly or fully responsible? Thanks, Stefan. Yeah, so it's both. The sun is the main driver of Earth's climate because of all the energy and light radiation that it releases. There are variations in that, and also in specific frequencies of light that the sun emits due to solar cycles. We have, for example, solar maximum, solar minimum, but we also have grand maximums, grand minimums. All that matters. But that's the energy coming in. How does that energy then get modulated once it's in the Earth? So the atmosphere is very important because the atmosphere determines the greenhouse effect, whether we have energy leaving or effectively staying. And well, we've been affecting the Earth quite a bit as a result of all our anthropogenic activities. So we have more water vapor in the atmosphere now. We have more CO2 in the atmosphere, more methane and other greenhouse gases. Water being the main greenhouse gas, okay? It's not just CO2. People, like, they're on both sides, they're overly fixated on CO2, okay? It's just like in politics, both sides are overly fixated on Trump. It's like, who gives a fuck, all right? Like, let's move on to what matters. But it's this mind virus. CO2 is another one of them. Water vapor is the bigger greenhouse gas, and in every single combustion reaction, you are producing a lot of water vapor, as well as CO2, and there may be some methane, whatever. It's mostly water vapor. So we've released a lot of new water into our planet because we had All of these plants exist across millions of years that then got sequestered into the geologic system as oil, gas, and coal, right? Millions of years of sunlight effectively being sequestered, that energy locked up, stored away as hydrocarbons. This is hydrogen, carbon, oxygen, right? What makes water? Well, it's hydrogen and oxygen. And what makes CO2 or carbon monoxide or whatever? Well, it's, or methane. Well, methane's a little different, but it's carbon and oxygen. Methane is carbon and hydrogen. So you see how you create these things just from 3 different elements. All that gets released into the Earth system. Earth has a lot of gravity. That water vapor isn't just flying off into space. I mean, some of it is, but in general, once you have a planet big enough, it can hold on to its atmosphere. There's a reason why Mars has a weak atmosphere. The Moon has almost no atmosphere. Mercury has almost no atmosphere. They're tinier. But once you're at like Venus and Earth size, and also our density is much higher, you can hold on to a thick atmosphere. Even though gas is energetic and wants to expand out, our gravity is stronger. So that water didn't just go away. It's now all in our hydro system. Plus you add in carbon dioxide and all this, and just add in the fact that burning a fossil fuel, coal or whatever it is exothermic in nature. It's releasing energy. You had something that had a high potential energy that was inert, which is now being liberated, millions of years of sunlight stored away, being released in a short time frame. On the human time frame, 200 years geologically, that's like faster than a snap of a blink of a butterfly's wing beat, okay? So it's crazy. Then you have the solar radiation in general still pumping in all the time. So it's effectively resonance amplification. You have us changing the resonance system of the Earth such that less energy is leaving while more energy is constantly coming in. And we're also, with all these combustion reactions, you know, and we're dropping bombs around everywhere, like we're fucking stupid. So excuse my French, but just like sometimes we got to like really see things clearly. We do a lot of dumb things. And so that's affecting our climate quite a bit. But doesn't mean that we're the end-all, be-all, complete masters of our climate, because let's say we get ocean currents to destabilize. That could send us into a global cooling phase really quick. So we're really playing with the system. You could think of it as like we're playing with the sandbox and building castles and everything with the sand, but then the Earth is going to shake. Like let's say there's an earthquake, all of a sudden your castles are flattened. Like, so the Earth is still in control, but we're definitely a much larger active player in this game now than we were 200 years ago. So I hope that answers your question. We've had a ton of solar activity in the 20th century. So really going all the way back to solar cycle 3, we've been in a grand maximum as well. Solar activity has been increasing for 300 years. So that also is a very important component to this. You can't look at just one side. You have to look at all the different factors, actually appropriately weight them and understand them, and forget any biases you may have, right? Leave all that nonsense programming baggage behind, step into a greater awareness of reality, a new consciousness, and you can start to see things clearly. That's what I think. That's my opinion. Take that for what it's worth. If it resonates, great. If it doesn't, then, you know, leave. That's fine by me. Best way to prepare, if you live in an earthquake-prone area, make sure you have supplies on hand, water, food, hand crank radio, etc. Have a plan as to what you would do, where you would go for your workplace, for your home, just in general. Like, know your environment. That's about all you can do for an earthquake. So it's really just kind of a wait and see game. They strike unexpectedly, so we don't know. That's the thing. We don't know. And a question from Golden Doodle is, can the Schumann affect brain, psyche, or brain pathophysiology, mood, stroke, seizures? Yes, absolutely. There's a lot of research on that. There's a super strong connection between our biology and Schumann resonances, but in general, actually, the larger geophysical system and energies of the Earth and our own bioelectric energies is called geobiology or geobiophysics. You can look into that because we evolved within this system. So we've evolved to be resonant with the system. So when there are changes to it, we experience these changes as well. And consciousness is connected to biology. It's not, 100%, but it's connected to it. So when there's changes to that, it also affects our consciousness to some degree. Collective, even at a collective scale, it's a little bit more clear because there's a lot of noise with individuals, right? Some individuals feel it, some don't. You know, sensitive, ultra sensitive, non-sensitives. But at the collective scale, you can see these shifts. Full moon effect. People go nuts during full moons. During geomagnetic storms, people are more volatile and kind of anxious and wired and snappy and all these things. So yeah, that's a huge area. I have a lot of videos on that actually. If you type in on my channel, like go to my channel page and click the search and type in Schumann, you should find some videos there. There's also some video playlists. A lot of people need to watch those videos if they haven't seen them. They only watch my daily updates, but I have some really good like hour-long, 2-hour-long guides that I've done in the past, which is where I recommend you go. So we're going to go to our super thanks questions now, because there's a lot of them, and I don't want to be here for 20 hours. Though I love you all. You're great. I love your support. Thank you all for being here. If you're new here, you're just jumping in, or you're wondering who the heck is this guy, I'm your host, Stefan Burns, geologist, geophysicist, space weather guy. Your cosmic bro here to help you understand what is happening with the Earth, our star, the sun, our solar system with the planets, interstellar space, cosmos, all that and more. I release videos almost daily on YouTube. I also have a X account that's at Stefan Burns Geo. It's all linked in the video description. You can listen to me on Spotify if you want. You can never come back again. Hey, it's up to you. You're a free, sovereign individual. Hopefully, becoming more and more self-actualized. That is the goal. So with that, we're going to get into our super thanks questions from the live streams thus far. I'm Anna. I'm in California. Will all of California be flooded, or will it be mostly coastal cities? My family's in Long Beach. I'm in Lancaster. I love Guy and support her much needed release. Yeah, I mean, we don't know at the end of the day what's going to happen, but I think it's a bit of a myth that California is all just going to flood, sink into the ocean. There is, some evidence that there can be subsidence at geologic scales. So, I mean, we saw that with Port Royal with a big earthquake in the 1600s. It was like a big magnitude 7.5, and 75% of Port Royal in Jamaica sunk beneath the ocean. But for all of California, we're talking like a massive Earth event. And this isn't going to happen probably in one day, but maybe happen over a long period of time. At the end of the day, I don't know, but this is one of these internet things that floats around that gets people freaked out, and half of it's attached to people hating California because there's a lot of Democrats that live there, and they hate liberals because they hate themselves, and so they want them all to die and drown a terrible, wicked death because they're wicked people, and that's what they get pleasure from. So it's just a stupid thing. You don't have to be worried. If you're doomed, you're going to be doomed, all right? So, live your life. Don't worry about these things. If it's really affecting you psychologically, move out of California. But I live there. I'm not worried about that. Some of it's based off of this Edgar Cayce prophecy, where he has this totally different map of the United States and the world after some severe event. But these psychics and mediums and everything, God love them. There's some stuff there to that, but there's also a lot of nonsense that gets made up and that's inserted into the collective psyche from that. That's just the truth. So I personally, that's what I think that is. I just think it's kind of made up nonsense. If I'm wrong, then we'll see. It doesn't matter if I'm wrong, but if I'm wrong, then we're doomed anyways. But this channel is not about doom. It's about, trying to see what's realistically going to happen or could happen, and hopeful future, and one that's higher consciousness. I think these are very low consciousness mindsets. So hope that answers your question. Thank you for your support of Gaia and all that. And our friend Gizem from Turkey, I'm really worried about my parents' flight on the 18th, 24 hours from Phuket to Istanbul. No, I think you're fine. I wouldn't worry about it. Again, same thing. Can't be worried about things you can't change. If I'm looking at solar activity for a flight I have coming up and I'm worried, I just cancel my flight and I change it. But the sunspots, we could get a big flare, but if these planes were dropping with every single solar flare, then there would be no flights because millions would be dying. So that's not the case. I wouldn't worry about it. Don't get yourself worked up. I think a lot of worry and fear comes from a lack of education on topics. So, the more educated and aware and abreast of this information that you are, then the less likely you are to be worried or more. I hope they have a safe flight, and thank you for the super thanks. That's very generous of you. I wish you the best. And from Amy Elizabeth, thank you for your super thanks. You asked a question in the last live stream. God, God, I can't remember what it was about. Moderator sent it to me. Something about California earthquakes, maybe. I think you've messaged me on Instagram. So if you want to send that question to me again on Instagram, I'll answer it for you there. Sorry about that. We were having problems with the last live stream. And Candy, thank you for the membership that was gifted. That's awesome. Old Trapper, thank you for the super thanks. What caused quake in Israel a couple days ago? I don't know. I know it wasn't big. You know, that part of the world gets earthquakes, so they happen. I wouldn't look. If it's under magnitude 4, it's almost never that I really examine it in detail because it's under magnitude 4. We have to really get to magnitude 5 or greater for things to be like significant to look at. So, you know, people be like, magnitude 2 in whatever, Hollister. Oh my God. It's like Hollister gets a magnitude 2 probably every single day. So certain magnitudes, though if you're right there, you may feel them. They're nothing to really like freak out about or spend hours researching because, well, it's nothing really crazy. So thanks for the super thanks. Much love, bro. Turtle2, thank you so much. Todd, why is the magnetic South Pole moving slower than the magnetic North Pole? That's a good question. Don't really know. I mean, the main idea is that we have these flux lobes in the northern hemisphere, and the magnetic pole in the northern hemisphere is moving from one to the other, from the Canadian to the Siberian, because the Siberian flux lobe has strengthened and the Canadian one has weakened significantly. That would explain the movement. We don't have that dynamic in the southern hemisphere. We only have one flux lobe down there. So you're not going to get that rapid movement because there's nothing pulling it. So that's probably why. But at the end of the day, can't really say definitively. Thank you, TJ, for the generous super thanks. Really appreciated. Wishing you the best. Blessings of abundance and love and more in 2026. It's really great. Thank you so much for your support. And Newbie is asking about the Great Rift Valley, probably in Africa. We did have that historic eruption of Haley Gooby in November. So that was quite significant. But we're not seeing any big earthquake activity there right now. I'm not necessarily worried about the Great Rift Valley at this moment in time. Longer time frames, we're seeing more activity from this African super plume. But in terms of this pre-earthquake signal, that's not where I'm looking. Who knows? We'll see. Doesn't mean, just because it's not where I'm looking doesn't mean that may not be where it occurs. But Africa typically doesn't get big earthquakes because it doesn't have that many faults there. Though the Rift Valley is different, so you can get a lot of activity there. Anything on the new Madrid fault line? Something tells me to ask. I believe I saw orbs in the sky last month. Appreciate you. New Madrid, we're not seeing any activity that would indicate something is coming. Doesn't mean we can't all of a sudden get it to happen. But in general, we see preparatory activity usually before big earthquakes. So if we start to see, these sort of foreshock sequences occur in and around that area, then we can think about, okay, maybe something's coming. But right now, that area is calm, quiet, seismically. We don't know when it's going to rupture again. It could be 300 years from now. Could be tomorrow. Could be hundreds of years from now. We don't know. At some point, it will. They get big earthquakes there. Magnitude 7.5 plus, even up to magnitude 8. But I'm not necessarily worried about New Madrid right now. Thank you for super thanks. Thank you, JP. Thank you, Gazem, once again for another one. Tracy for the super thanks. Tornado Dozer for the super thanks, and the Blazing Army. One second. Okay. Hi, Stefan. Reading Robert Temple's book, which is A New Science of Heaven. Would you be open to including a reading list on Earth evolution? Yeah, it's a good idea. I have a page I could put that on, be the research page. So I'll think about that. Let me write that down. Reading list on earthevolution.com. Yeah, it's not a bad idea. Thanks for that suggestion. There's a lot to do. I have too much to do already, but I'll think about that. And if it's easy to implement, then I'll do that. So thank you for that. And yeah, it's a great book if anyone's interested. New Science of Heaven by Robert Temple. I'd also recommend The Body Bioelectric by Robert Becker, The Holographic Universe by Michael Talbot, anything from Hans Alvin, Plasma Universe, the Evolution of the Solar System. There's a lot of really good material out there on things like this. And if you're interested in geology, just pick up a geology textbook, like an undergraduate geology textbook. It may cost like $100, $200, but it'll be thick and full of info, earthquakes, volcanoes, faults, layers, everything. That's mineral types and rock types. That's a good way to learn. Just flip through that over time. Diva369, thank you for the super thanks. I just learned that Voyager has detected a superheated plasma wall of fire reaching up to 50,000 Kelvin at the limit of the heliopause. You discussed plasma recently. Is there a connection? Voyager made those discoveries decades ago. It's passed through that wall of fire now. Now the Voyagers are outside of the heliosphere, just outside of it, and the boundary between the heliosphere and the interstellar medium. So yeah, it's really cool. We get this condensation of plasma that gets superheated and more dense than magnetic field spikes at the edge, at the boundary of the heliosphere and interplanetary space, or interstellar space rather. But this isn't, for example, I get the sense that you're kind of asking this question about it being relevant right now. It's always there. So maybe not, but yeah, it's not like a new dynamic. But there's a lot of channels that will take, let's say, maybe some old, not old, but something like that and kind of spin it into something that's like happening right now that means we're all doomed, something like that. I don't know what you watch. It's cool stuff though. I mean, I have a video on interstellar space that you could watch on the channel if you want. I believe it's still up. But yeah, there's a lot of cool things in our interplanetary environment, and that's one of them. You know, our plasma bubble, it affects us in a very deep way. There's been an ongoing earthquake swarm around Belaskir, especially near Sindirgi. Apologies. From a geologic perspective, what processes are most likely driving this? Is it stress release on complex faults or something more complex? I'm not sure what you're talking about. So let's look at the map and see if we can find out what you're talking about. But yeah, we've been getting earthquakes here for a while now, actually. So this isn't too crazy, to be honest. And I zoomed in too much. Here we go. Let's punch in like that. I don't know the magnitude on this. Magnitude 1. Magnitude 2.1. This is going to be just local faults having some stress relief. We have had some magnitude 4s and 5s in this area over the past 6 months. The big area that we're looking for an earthquake in Turkey would be near Istanbul because of the North Anatolia fault. This is where we had the Gaziantep earthquake sequence, 7.8, 7.5. We could get a big earthquake anywhere in here near Izmir. We don't really know, but I wouldn't really look at these and be concerned. In general, I think Turkey's had a big release of energy recently, and it's not top of the list in terms of a big earthquake coming up. But who knows? You guys get a lot of earthquakes, so anything is possible. And with that, let's look at our data one last time, see what's come in, and then I'm going to sign off. I'll keep you all up to date on the channel. So please subscribe, X, everything. You can follow me there. We are still getting this data to come in right now. This is, again, 12 hours up to the 0. It's actually 12 and a half, and now we have it going, especially this lower frequency portion there, going all the way up to 3. So we're at 15 and a half hours now of this anomalous signal in the Schumann resonances. I think that we're likely to have something big in the next week as a result of this. The primary time frame is the 20th to 24th of January, but it could be as soon as right now through the new moon, which is the 18th. But in general, that Tuesday to Friday time window is looking the most critical, you could say. So we'll see what happens. Central Asia, like all the stands near Islamabad, that zone in general, that is the primary location I'm looking at, but also Japan, California. Who knows at the end of the day, but those are the zones that are showing the most anomalous activity right now at this moment in time, or they're the most overdue, etc. And if I had to really pinpoint a magnitude on this, I would say magnitude 7, even magnitude 7.5 or greater. I wouldn't be surprised if we get a magnitude 7.5 in Central Asia in the next week. We'll see. We hope that's not the case. I don't think it's a low likelihood. I think it's a high likelihood, which is why I'm making this video. So this is dynamic. I will be posting a lot of updates on this on my X account. So follow me there to stay fully informed with what I find, and then I'll release new videos as necessary. Thank you all so much for being here in the live stream. Thank you, moderators, for helping keeping the chat under control, all that. And thank you all for your good energy. Please say prayers just in general. These earthquakes can be quite destructive. We hope nothing happens, but we've seen before how these pre-earthquake signals are really good heralds of something big coming. So we want to be aware, prepared of that. Wishing you all well. Please take care of yourselves. I'll see you all very soon.